Have you ever stopped to think that every single day, tons of butter disappear into bakeries, kitchens, and breakfast tables all over the world? It melts over bread, gives a glossy finish to the pan, and even slips quietly into cakes and sauces. But behind that simple yellow stick lies an industrial chain far more complex than it seems. And today, we're talking about real butter. Made from cream, not that butter, flavored spread you see at the supermarket. And here's something you should know right now. When you see butter flavored on the label, it almost always means it's not actually butter, but another fat trying to imitate its taste. Now, think with me, how many gallons of milk do you think it takes to produce just one stick of butter? 10? 20? In some factories, a single production line can turn thousands of gallons of milk per hour into perfect blocks of butter, with the same texture and the same flavor without missing a single day. But almost no one sees what happens between the cow in the pasture and the butter shining on your table. Anyone looking at the finished product on the shelf would never imagine how many machines, sensors, and engineering decisions are involved in making that little block soft, flavorful, and safe to eat. A very warm welcome to Factories and Facts. Here, we show you in detail how the industrial world works behind the most common products in your everyday life. And in today's episode, you're finally going to see the step-by-step process that transforms a white liquid into one of the most beloved ingredients in the kitchen. And if you were already surprised in the last episode by everything sunflower seeds have to go through before becoming oil, just wait until you see what milk has to endure before it becomes butter. Butter has been part of human history for more than 9,000 years. Ancient peoples discovered, almost by accident, that when milk was carried in leather bags tied to horses, the constant motion churned the cream until solid clumps formed. And that was already the birth of a product that would outlast empires, wars, and industrial revolutions. But here comes the question that changes everything. If the basic principle is simply churning cream, why does a modern factory look more like a high-precision laboratory? Today, you're going to walk through those invisible doors and step inside the routine of a real butter factory. We're going to follow the path of milk, understand how cream is separated, discover the exact moment it turns into butter, and see how all of this is controlled down to the smallest detail to prevent waste of raw material. And before we step into this incredible production line, go ahead and subscribe here to Factories and Facts. That way you won't miss a single episode. And tell me in the comments, are you team butter on toast in the morning? Or do you only use butter when it's time to cook? To understand how butter is born, we need to go a few steps back and start exactly where it all begins. Out in the pasture. There, each cow is like a small biological factory programmed to turn grass, feed, and water into one of the most important liquids in the food industry. Milk. The quality of the butter starts being decided right here, long before any machine comes into the picture. The breeds used for dairy production are chosen precisely for their ability to produce large volumes of milk with a good fat content. The more fat the milk contains, the more efficient the process of turning that liquid into butter becomes. Feed also makes a difference. Cows that graze on certain forages can produce slightly yellower milk rich in carotenoids, which directly influences the color of the final butter. On modern farms, milking barely resembles the classic image of a bucket on the ground anymore. Instead, automated milking parlors use teat cup clusters connected to hoses, vacuum pumps, and sensors. These systems draw out the milk gently so the animal isn't hurt, while also measuring volume, temperature, and even signs of possible health issues, such as inflammation in the udder. The moment the milk leaves the cow, the clock starts ticking. It has to be cooled quickly, usually to around 4 degrees Celsius, to prevent excessive bacterial growth. This is done in stainless steel tanks with cooling coils. There, the milk is stored for a short period while waiting for the tanker truck that will pick it up. All of this happens without breaking the cold chain because any lapse can compromise an entire batch. Transport to the plant is another story in itself. Insulated tanker trucks with stainless steel interiors arrive at the farm, connect a hose to the tank, and pump the milk out. Before they leave, a sample is taken for analysis. From the farm gate to the factory entrance, there is a strict time limit. It's not simply a matter of load it up and go. The pickup schedule is designed so the milk always arrives fresh and within spec. When the truck arrives at the plant, it can't just unload its contents and drive away. First, technicians take new samples for a battery of rapid tests: acidity, density, fat content, presence of medication residues, bacterial count. If anything falls outside the standard, the batch can be rejected. Only after these tests is the milk cleared to enter the factory's massive storage tanks. Inside the industrial plant, the environment is almost entirely stainless steel, clean and tightly controlled. The milk goes through processes such as pasteurization, where it is heated and then rapidly cooled to eliminate pathogenic microorganisms. Then comes the key step for butter: cream separation. This is where industrial centrifuges come in, true milk spinning machines operating at extremely high speeds. These centrifuges use the difference in density between the fat and the watery portion of the milk. As everything spins at high speed, the fat, being lighter, concentrates in one area, the leaner portion moves to another. In a matter of seconds, the entire milk stream is split. On one side, fat-rich cream, the foundation of butter. On the other, skim milk, which can be turned into other products, such as milk powder, yogurt, or dairy drinks. This is the stage that surprises a lot of people. Much of what gets said out there about industrial butter is myth. Instead of mysterious mixtures, the heart of the process is physical treatment: heating, cooling, spinning, separating. What the industry does here is repeat, on a gigantic and controlled scale, the same logic once used in the past, by hand, when milk was left to rest until the cream rose to the surface. To give you a sense of the scale, a single modern centrifuge can process thousands of liters of milk per hour, separating cream and skim with far greater precision than any manual method ever could. Imagine trying to skim the cream off each bucket of milk one by hand. Here, everything happens continuously, in a flowing stream, like a conveyor that never stops. That efficiency is what makes it possible to keep supermarket shelves stocked on a massive scale. As the cream is separated, it is directed into specific tanks where its fat content is standardized and the temperature is adjusted. These two factors, fat and temperature, are the passport to the next stage of the journey. The moment when the cream stops being just a thick liquid and begins preparing to become, in fact, butter. And by now, you can already tell this yellow block is far more high-tech than it looks, right? And if the behind-the-scenes journey from the farm to cream separation surprised you, go ahead and leave a like on this video. That helps Factories and Facts reach more people curious about the industries that keep everyday life moving. Now that the cream has been separated from the milk and stored in dedicated tanks, the most symbolic stage of this entire story begins. The moment it stops being just a thick liquid and starts turning into the butter you know. This transition does not happen by accident. It is the result of a precise combination of fat content, temperature, and continuous mechanical motion. Before entering the large industrial churns, the cream goes through fine adjustment. The plant defines exactly what fat content it wants to work with, for example, something around 35 to 40%. If it is below that, the cream is concentrated. If it is above, it can be blended with a leaner fraction. Next, the temperature is adjusted with great care. Just a few degrees higher or lower can completely change the final texture of the butter. With the cream standardized, it is sent to equipment that at first glance looks like giant stainless steel cylinders. These are known as churns, or continuous butter makers. Inside, these cylinders have paddles and chambers spinning at high speed, churning the cream non-stop. What looks like nothing more than violent shaking is, in reality, a carefully controlled physical process. Chemically speaking, cream is an emulsion of fat droplets dispersed in water. As the equipment agitates the system, those droplets begin to collide and merge. It is as if the churn is forcing the fat to cling together in larger and larger masses. After a while, the structure of the system flips. Fat stops being the dispersed minority and becomes the continuous phase, trapping tiny droplets of water. This phenomenon is called phase inversion. In practice, the operator does not talk about emulsion or continuous phase. They watch the texture and behavior of the product. At a certain point, the cream stops looking like a thick liquid and begins forming small yellowish grains, almost like tiny butter pellets floating in a whitish liquid. That liquid is buttermilk, which is essentially the remaining liquid left behind after the cream is churned. As the cylinder keeps turning, the equipment separates the buttermilk from the butter mass. The liquid portion is drained through specific outlets and can be reused in other product lines at the plant. The solid phase, the butter taking shape, continues through the process. Here, the factory has to find the balance between efficiency and quality, removing enough liquid to guarantee stability without making the butter too dry. Depending on the final product, the butter may be unsalted or contain a specific amount of salt added evenly throughout. The salt is added in mixers that keep working the mass, now at a lower speed, distributing the ingredient throughout the butter structure. At the same time, the system also works on texture, breaking down larger clumps and making everything more uniform. In some markets, the color of butter is standardized as well. That does not necessarily mean artificially coloring the product, but adjusting its appearance so the consumer always finds the same characteristic shade on the shelf, even with natural variations in the cow's diet. Everything is done within limits defined by regulations and internal quality standards. The most delicate point is temperature control throughout this entire path. If the butter gets too warm, the fat can separate and leave the product oily, overly glossy, and without structure. If it gets too cold, it can turn into a hard, brittle block. That is why sensors placed all along the line continuously monitor conditions and adjust cooling or heating whenever necessary. At this stage, the butter already exists, in fact, but it is still not in the form you see at the store. It is a homogeneous mass, ready to move on to the final working, shaping, and packaging stages. Even so, much of what defines the consumer experience, such as how easily it spreads on bread and its sense of creaminess, has already been decided here, inside these steel cylinders no one ever sees. And it is remarkable to think that something as small as a 2 or 3 degree difference in cream temperature can determine whether an entire batch will meet the brand standard or have to be reworked. In a plant of this size, controlling these parameters is almost like flying an airplane. Everything has to be monitored and corrected in real time. If by now you are realizing just how much engineering and science stand behind that little yellow block in your fridge, I want to hear from you. Leave a comment below and tell us whether you prefer salted or unsalted butter, and where in the world you're watching Factories and Facts from. That's how we discover just how far this production line is reaching. Once the butter has been formed, washed, and adjusted for salt and texture, the stage begins where everything has to be fast and precise. From this point on, any unexpected stoppage can mean the product losing its ideal consistency, machinery coming to a halt, and a domino effect across the entire plant. The butter mass leaves the churns as a uniform block and moves through stainless steel piping to equipment that performs a kind of final kneading and homogenization. It is like an industrial knead. Screws, paddles, and cylinders work the butter to remove air bubbles, break up small clumps, and ensure that the salt and moisture are distributed evenly. At the same time, pumps maintain a continuous flow, turning the butter into a stable stream ready to be shaped. Next comes shaping and portioning. The butter is directed into molds that form 100, 200, and 500 gram sticks, or larger blocks used by bakeries and food manufacturers. Machines with automatic blades and wire cutting systems define the exact size of each piece while the conveyors keep moving. The product never stops. The line adjusts itself to the flow. Right after that, the sticks enter the high-speed packaging area. Rolls of special paper, often laminated to protect against light and oxygen, are unwound. In fractions of a second, arms and guides wrap the stick, fold the edges, and seal the package. It is like watching a folding sequence repeated thousands of times per hour, always with the exact same pattern. At this stage, weight and shape are critical. Dynamic scales mounted on the conveyor weigh each unit while it is still moving. If a stick comes in below the declared weight, a pneumatic device removes the package from the line. In some cases, cameras and sensors also check whether the shape is correct and whether the package was properly sealed. All of this happens without interrupting the flow. Before moving on, many systems also pass through a metal detector. The goal is to ensure that no metallic fragment has entered the product due to part wear or an isolated accident. If anything unusual is detected, the package is automatically rejected and set aside for investigation. As they move forward, the package sticks reach the area where case packers assemble cardboard boxes. Mechanical arms or operators place the units inside in organized layers. The boxes are sealed, labeled, and stacked onto pallets, still in a refrigerated environment so the butter's consistency is not compromised. While the line keeps running, quality control tracks everything in parallel. At regular intervals, samples are taken and sent to the in-house lab. Technicians check fat content, moisture, salt, color, texture, and perform microbiological analyses. Some tests simulate what the consumer actually experiences: spreadability on bread, flavor, and aroma. If anything falls outside the standard, the batch can be traced, the process can be adjusted, and the problem can be prevented from happening again. When the results are within the expected range, the palletized boxes move into cold storage, large refrigerated rooms with controlled temperature. There, the butter waits for the shipping schedule. Refrigerated trucks pull up, receive the load, and head out toward distribution centers, grocery stores, bakeries, and restaurants. In just a few hours of production, the plant generates enough butter to stock shelves across entire regions. For someone at the store, it all comes down to picking up a stick of butter from the shelf and dropping it into the cart. But behind that simple gesture lies a production line that blends mechanics, automation, sensors, software, and many specialized people to ensure that every unit is as identical as possible to the one before it. With the butter palletized and stored in cold rooms, the final stage of this journey begins. leaving the plant and reaching your table intact. Here, the main player becomes refrigerated logistics. Throughout this entire route, the rule is the same: never break the cold chain. Every stop, every unloading, every time the truck door opens is time to prevent the temperature from rising too much. That is what ensures the texture the factory works so hard to perfect stays the same until the moment you open the package at home. When the butter finally reaches the shelf, it blends in with hundreds of other products. But its destination is far more varied than simply spreading it on bread. And there is not just one kind of butter. Beyond the classic salted and unsalted versions, there are types developed for professional use, with fat and moisture levels adjusted to better withstand oven heat or give more structure to specific doughs. There are also clarified butters and the famous ghee, in which virtually all the water and milk solids are removed, leaving almost nothing but pure fat, widely used in kitchens that work at higher temperatures. In the middle of all this, many people still confuse butter with margarine. Visually, the two can look similar, but their origins are different. Butter comes from milk cream, while margarine is made from processed vegetable oils. Both have their place in industry and in the kitchen, each with its own technological and sensory advantages. But it is fascinating to realize how two products that look so similar on the plate come from completely different industrial processes. Remember the question from the beginning? What happens between the cow in the pasture and the butter shining on your table? Now you know that along the way, there are structured farms, tanker trucks, centrifuges, giant churns, sensors, laboratories, and packaging lines that cannot stop. And I want to hear from you. Which part of this butter journey surprised you the most? Was it the automated milking, the cream separation, the churning that flips the emulsion, or the high-speed packaging line? Tell us in the comments. And go ahead and subscribe to Factories and Facts if you are not part of this community yet. Here, we open the doors to industries you almost never see, but that stand behind practically everything you use and consume in everyday life. And if you think you've already seen it all, then you have no idea what factory we showed in our last episode. It should already be appearing on your screen. Click, and come with me to uncover one more hidden secret here on Factories and Facts. A big hug. I'll see you there.